Good afternoon, my name is Sean McRoby and I will be walking you through my compiler today. First off, I'm going to show you all the pieces of my test that we're going to run through. The first thing the test is going to do is it's going to reset all the variables, and then we're going to slowly print out each and every piece. I also wrote evaluators for each piece that we can call upon if we need to. I'm actually going to add those real quick. So, first up, we print out the R expression, and then what we're going to do is we're going to flatten it, which I'll run through, and then what we're going to do is we're going to print that out in the new line, and then we're going to select it, print that out as well, and then the last thing we're going to do is homes. Patch is not currently implemented, it's the last little piece that I was working on but didn't have time to finish up. And then the last thing we're going to do is we're just going to call eval on the X program. There's also evaluators on the C program and the R expressions that I will show you as well. So first up, we're just going to run the program. As you can see, I have a couple different tests here. Scroll all the way to the top. So we have a read, which turns into a read after uniquify, which is right here. And then it turns into a C program. As we flatten it, we print that out, which calls correctly and has all the pieces. And then we print out the X program after we select it. This just uses regular variables that we passed along. We didn't add anything to them or turn them into registers just yet. And then the last pass is we go through homes, which isn't really necessary for read, but if we scroll down here, just as a basic pointer allocation, so we add this part, which initiates the base pointer, moves the stack pointer to the base pointer, and then we subtract the amount of space we need. I do that all at the beginning, regardless of how big the program is. That's just how it's implemented for now. So this one allocates 32 because we need the extra space. So I'm going to walk you through some of my pieces. First up, last time on my presentation we went through all the R expression stuff, which is pretty much the same as yours. The only thing I changed is, since I'm in C++, I passed through pointers. I did not create my own map, I just used the map that is included in the C library. So if we go up above our expressions, we can move on to C programs. I'm going to start with program, and I'm going to go through each of the pieces. Alright, so the C statement, it's public to the C statement class, and we have CAssign, which is the only piece to it. As a variable pointer, expression pointer, and then it's going to assign it basic. The toString function is what you see over on this side, and the evaluator is also here. All the evaluators are functional. We'll print those out at the end just to show you that they do work at every stage. It was helpful for me to see that I was adding together the right numbers. So here are the pieces to the C expressions. We have CAdd, which again has a basic initializer function, string function, the evaluator, and it also has the select function, which takes all of the C expressions and it turns them into X instructions, and then it pushes them into the list that I'll get to a little bit later. I'll show you that. C negative, same thing. C read has all the same pieces. This is C expression, which is, or the C expression argument, which is public to the C expression, which has the embedded argument here. And again, it has all the same basic pieces. These are the two descendants of CArg. You have CAint, and then you have the CAref. And again, you see all the same pieces implemented, and I'll show you the virtual functions when we get to the basic structures. Again, I had to add all these overload operators just so that printing them out as strings over on this side would be a lot easier. because I can simply just put it in the cout in my test function and it prints right out for me. Alright, so for select, this is part of the C program. So the C program is made up of a var set of var pointers, and all these stuff are pointers. So a lot of these things I just passed along the pointer and they return void. So if we go to xselect and we're looking at the master list and the temp, and it pushes through the iterator, and each time it's going to call select and it's going to put it in temp, and then the master is going to insert at the end of its list, and it's going to insert the whole temp list. The reason I do it like this is because just in case xselect returns multiple instructions, and at the very end I do master and I push back the very last important piece, which is the return piece of the C program, and I give it a reference rex, and then I return that as a new program, as a new X program. I didn't really feel the need to use the technical structures that you had listed. I'm sure if I went further on in my compiler, I would have found need for them, and I could have replaced them as I went along. But I decided to start here for now, just with a simple vector, a simple list, and just an arg pointer for the return value. So these are all the basic structs and all their virtual functions the descendants spawn from. So we have the carg, which is the basic, and we have all the virtual string int, xarg select, again string int, C expressions, and then we have the C statements. If we scroll further up, when I was adding additional pieces to my code, instead of just doing clarifiers, I just coded upwards. I just did the X program on top of all the C stuff, and then all the C stuff on top of all the R expression stuff. So that way if I referenced it, I wouldn't have any trouble locating it. So down here on the X program, we have two different types of X programs. We have the basic X program, and then the X program -h, which is just returned after you call homes, or assign homes, which I just titled homes. The X program is just a list of instruction pointers to be more specific, and again I can just pass around the instruction pointer to the list, which is incredibly helpful for some of the functions, especially like the eval and patch. So if I go through these two, excuse me. So if I go through these two, the evaluation function creates a store, and then what it's going to do is it's going to pass the store and the iterator to the list of X instructions. What it's going to do is it's going to call eval on all the separate pieces. Again, I just used regular lists, and I used the overloaded operator that instead of insert. That way, if the value, say right here, if you had something like move q8 to -2, and then you had to take that value from -2 with 8, and then you negate it, and then you insert it back into -2. If you use insert, it wouldn't emplace it. It would just fail, and you would have to catch it. So instead, I just used the operator because I know all my variables will be unique after the uniqueify pass. So that was interesting to kind of combat that. It was hard at first, but then I understood what was happening and how I could utilize the different ways to insert into the list when I needed them to fail, or if there's something there, or if I needed to replace them when there's something there. So these are my X instructions. Let's scroll up to the basic struct, which doesn't contain anything but virtual functions that I'm going to fill in each piece, and then X arguments, again, which is right here. So if I scroll down, we have the href, which just has an embedded variable, and it's public to xarg, and it has the reference function, it has the assign function, which is your set function. I just use assign because it's easier for me to think about. I just always think of it as assignment. And again, this is the binary operator that I was talking about that's overloaded that I used this way. If there's something already in the map with that key, it's going to just replace it with a value given. And again, since Uniqify functions properly, I am certain that it will not replace any valuable information. The value information from, say, whatever variable you're looking at, here again at -2 is pulled out before you try to replace it with a new value. So you pull it out, you negate it, and then you insert it back into the spot with its proper key. Homes here is just basic dereference, and I just sent along a count. That way I can just increment by 8 every time I need new space. Just as a simple comparison here, if it's already been, the label's already been changed to a dereference of the register RPB, then it won't execute any of this. Stops it from increasing count overly necessarily so. We won't worry about patch because it didn't go through. I can show it at the very end though. We have XA_int, which just has an integer, simple constructor, reference assign. I just throw, just like you did, that it cannot assign to integer in case a program accidentally attempts to do that. The toString function prints out the numbers, the money sign with the integer. Xmove, so these are, what we're looking at here is now going to be all my X instructions, or all the implementations of them. So if we look down, we have move, which takes in, I just store everything in source and destination. And we use assignment, which works properly. You give it the store when you're trying to evaluate it. ToString, you simply return move Q, and then you return the source, comma, and then your destination, so that works properly as well. So you have the source and the destination. Homes, all that does is it just goes to the source and destination, and then if it's an integer, it will do nothing, and then if it's a variable, it's just going to rename the label, just so I can print out the new version with all my dereference operators, or dereference registers. Patch isn't functioning, but I can show that at the very end. Read, it's the same type of deal, it has a destination, simple constructor. The eval works, toString works, and homes just call us the destination and make sure that that it has been properly relabeled. Next up we have add, which says similar things. It just has a source and destination. The eval function does work properly, which is nice and satisfying. It pulls the data from the store for each. If it's an integer, it just pulls the integer, and then it takes that and puts it back into the store at the variable of the assignment. So obviously over here, if you have add Q or add 1, it will pull both pieces of data and then put it into add 1. X negative, similar, not a big problem. Things I would do differently. I definitely struggled towards the end with figuring out where I wanted to go with the assembly code. I was looking towards the book and its rules and regulations. I was finding hard to find what kind of syntactic rules that were necessary for x86. The only thing it really seemed to list is that you could not have an instruction that referenced 2 pieces of memory. And it's been a while since architecture, so I was struggling to find on the internet like exactly what I needed to do to get this code to the last point it needs to be. Obviously, I just need to patch it so it incorporates the RAX register. That's what I was working on, or any other register if the RAX register is already being used. Creates the new instruction so that it functions properly, and then the last thing I want to do is just fix all the syntax, and then it would be a full assembly code. I would definitely try to combine patch and assign homes. Hold on, if I look here. Homes and patch, and even when you just did select, I think would be a reasonable time to simply get rid of all your variables and start I was thinking more along the lines of creating a map to store the different registers, see which ones were being used, maybe a map with a map of variables and bools to see if it's currently being used, and then within that would also be so it'd be a map of a pair of variables to bools, and the second aspect of the outer map would be obviously the integers, so that I could see all the data that I needed to, so when I want to evaluate. It definitely got a lot easier towards the end when you creating the structs again and again. Creating the C structs was hard because I required a little more pieces. Converting from the R reference or the R expressions to the C language was definitely one of the hardest steps for me personally. And that's probably why I simplified some of the data types I was using. Just using vector and a list and C arguments until I found the need to replace them with something more audacious that would be more useful to me. In the future, obviously, I just want to finish up this, and then I would definitely go back, especially towards patch, home, and select, and see if I can combine them in relative ways just to clean them up way more than they already are. Other than that, it's been a good learning experience, and I hope you have a good day.